And body moves along a coordinate line in such a way so that its velocity at any time t, where 0 is less than t is less than equal to 4, is given by t times the square root of quantity 16 minus t squared. Find a position function x of t, assuming that the body is initially located at the origin. Okay, so initially located at the origin, that gives us our initial data. So the concept here is we have velocity with respect to time, which is x prime of t. Or one way to think of this is, so this is derivative of x with respect to t. One way that I kind of remember this in my head is that my car goes in miles per hour, where hour is a time and miles is a distance. So this kind of makes sense that velocity is a change in position with a change in time. Velocity is the first derivative with respect to time of position. So if you have position, take a derivative with respect to time, you get velocity. And then to go backwards, you'd want to integrate with respect to time. So integrate with respect to time. Therefore, then you'd have position will equal the integral of velocity with respect to time. Long story short, to get from speed to position, you do an integral with respect to time. And that's what they're asking us to do here. They're giving us velocity, v of t, and they're asking us to find x of t. So they want us to take the integral of v of t. So we'll do integral of t times, I'm going to write this as 16 minus t squared to the 1/2 dt. So this here, we're going to solve it using u substitution? U substitution, yep. Because you see, you have when you take the derivative of 16 minus t squared, you're going to get something that's kind of sort of related to t. And if we're wrong, we'll try something else. Not a big deal. It's okay to be wrong in math. Or it's okay to make the wrong decision, to take the wrong path. Try not to be actually doing your calculations incorrectly. That makes life a lot more difficult. 2t, negative 2t dt. Therefore, we have negative 1/2 du equals t dt. T dt. Plug in our substitution using blue. And then we have integral of u to the 1/2. And then we have a t dt right there. Negative 1/2 du. Yep. And then this will equal negative 1/2. And then see here, we have a u to the 3/2 times 2/3. Just doing the power rule. 2's will cancel. And this will equal, well, I'll do a plus c. I'll say c1. That way I don't confuse it with the c that we'll have later when we switch back to x. So we have negative 1/3 u to the 3/2 plus c1, which equals negative 1/3. Now I had to plug in our x, or t. 16 minus t squared. 16 minus t squared to the 3/2 plus c. Okay, so now we're also told, though, that it was initially at the origin. So I'm going to assume that means that x of t equals 0 will equal 0, which in this case we'll know will equal negative 1/3 16 minus t squared to the 3/2 plus c. Okay. Oh, this t here is actually 0 because we started at t equals 0. So simplifying this, we have negative 1/3. Now, to find 16 to the 3/2, the way I'm going to look at this is I'm going to look at this as 16 to the 1/2 cubed. So 16 to the 1/2 is 4. 4 cubed is 64. So we have 64 plus c equals 0. C equals 64 over 3. Okay. No, it wasn't too bad at all. Okay. Put it all together. Purple, dark purple. Ah, too close. Light blue. X of t equals negative 1/3, 16 minus t squared, 3/2 plus 64 over 3. There we go. And that should be our answer. Oh, see what some of our options are. Move this guy over here. Straighten out slightly. So let's see, we have negative 1/3, 16 minus t squared to the 3/2. Aha, bam, yes. Go team. So this will be our answer right there. Backtrack, look and see what we did real quick. So we were given a position of velocity with respect to time. We're told to find its position with respect to time. So since velocity is the derivative of position with respect to time, we would want to take the integral of the velocity function with respect to time to get back to the position with respect to time. And then when we do that, we're given some sort of constant, which we have to find out. And we were told that initially means t equals 0, and origin means x equals 0. So at time t equals 0, x equals 0, plug that in, solve for c, and there we have our equation. So not too bad. You'll see this concept of position, velocity, and acceleration from time to time. They're not too hard. Try not to get too bogged down with the words and the phrasing and the semantics. Keep your head above water, do well. See you next time.